Okay, hello everyone, my name is Faye, and in this particular video, we're gonna talk about recursive. Okay, so recursive is a function that always calls itself. Okay, so if you have a function that call another function, it's not a recursive. Okay, this is my misconception before that I think if you see a function call another function inside it, it's a recursive, but it's not. Recursive is always call itself. It it looks similar to loops. Okay, it always do something again and again and again. That's what recursive do. So every recursive always have its own loops format. Okay, like that. So and I think the best way to explain to you about recursive is by do the tracing by yourself, because this is really just the key of recursive is to thinking about the tracing and how the programs works. Okay, but I want to highlight some of key components of recursive, which is we go to this week 4. Okay, oh no, week 5. So uh, wait. So the key component of a recursive recursion. Okay, so this you will always have okay, let's see this example. Okay, you see the green highlight is a base case and else is the recursive case. Okay, recursion case. This is what you do. So if you thinking about loops, it needs to stops, right? And you always declare it first, how the loops will start and how it will end. But in recursive, what you do is always try to have a stop condition in your first if sentence, which is your base case, and your recursion case, always try to reach that base case. Okay, so what this code do? Let's see. That's the basic components. You have a base case and recursive case, but I think the best way to explain to you guys is by this code. Okay, function direct, you have x as an integer, and as you can see here, where is the base case? The base case is if x equals to 1. This is your base case, and all other cases is to reach this case. Okay, so if I have x mod 2 is 0, then return direct x minus 1 plus x, else return direct x minus 1 minus x. So as you can see, I call inside this function, this direct function calls its own self. Okay, it return direct x min 1. As you can see here, we have a base case that it says x equals to 1. And every function calls, it's always minus the x value by 1. So if in example, if you have input 4 and we do the tracing, I always thinking it as a3 like this. Okay. In this first condition, we go to the x mod 0. Okay. Before we start, this is the first, second, and third condition. Okay. In this first input, we started from second condition because 4 mod 2 is 0. Okay. After that, we calls the directory. Okay. It calls directory. It goes to the third condition. And after that, it goes to the direct 2. After that, it goes to the direct 1, which is reach the base case. When it's reached the base case, it do returns 1. So if you see here, we have deret 3 plus 4, deret 2 minus 3, deret 1 plus 2, and we have our base case 1. The programs cannot stop on deret 1, deret 2, deret 3. It will continue until deret 1 value is 1, like this. So you will start from the bottom to deret 1, and you get 3, you get the value of deret 2, 3 minus 3, 0, you get the value for deret 3, value will be 4. This is the best way to do a recursion understanding by visualize it as a tree. So this is why I explained to you like this. Okay, so see you in a next video.